Hello, my name's Derek Bailey. I've been a wood turner now for over 40 years and I've taught for the last 8 of them, although those days have gone, I think. Having spent a few months using the carbide insert tools that require very little skill to use, the essential tremors of an old codger, which I'm sure you may have noticed in my previous videos, proved a little bit tricky for me to use them. I could use them, but it was more difficult for me. And I've longed to return to the more traditional turning tools, which the bevels on them allowed me to slowly introduce the cutting edge to the wood. The carbide cutting tools cut immediately and at times were quite unforgiving of a shaky approach to the wood. With that in mind, and the high cost stroke practice needed for the grinding traditional tools, I've designed a tool sharpening system to maintain the cutting edge of traditional turning tools. Although in the long term it's not a good substitute for manufactured systems, it should give you a start and allow you to assess the financial investment at a later stage. Anyway, I hope the 2-part video proves helpful, and enough waffling, let's get on. To make the disc sander, I'm going to use the hand wheel at the rear of the headstock and make a wooden faceplate to suit it. I'd recommend using a hard timber such as beech or oak for this. If you noticed, the lathe stopped or stuttered once or twice due to the fact that I'm using a square carbide tip tool which is very grabby and because of its width tends to take off a lot of material at once if you're not careful. Having used this square tipped carbide tool to reduce the wood to a cylinder, I'm now using the round carbide tip tool to do the finishing cuts to the size required. It's less grabby and easier to control the cut. As per usual, I'm creating a dovetail spigot so the wood faceplate can be held in the forge-o chuck. I'm now making a recess in the wooden faceplate to fit the hand wheel of the lathe. I'm nearly to the right size, so I just use a little bit of 120 grit just to finalise the correct diameter for the hand wheel. I'm now creating a flange so that I can make 8 holes for fixing to the sanding disc. I'm going to drill and tap 3 holes to fix the hand wheel into the wooden faceplate. I'm using the drill jig from my 5th video to do this. Just check that by doing this you may infringe the warranty of the lathe, which if I remember correctly is 3 years. It shouldn't do, but you never know, so I'd check. To get round that, you could always order a separate spare part hand wheel and leave that to one side. Once I've established the 3 holes using a 4mm drill, I'm going to widen the holes to 5.5mm, which is the correct diameter in order to tap an M5 thread. Because the hand wheel of the lathe is made of aluminium, it should be okay to use the combination drill and tap without breakage. Normally I wouldn't use them if I was going to tap into steel. After drill and tapping 3 holes, I'm now remounting the hand wheel into the chuck to take off the spigot from the back of the faceplate. I need to make sure that the rear of the wooden faceplate is perfectly flat or slightly convex in order for it to fit against the sanding disc without any movement. I'm going to use my good old indexing jig to drill 8 holes in the bottom of the wooden faceplate, ready to fix onto the sanding disc. It's now time to make the sanding disc. I'm using plywood for this, but you could use MDF, although plywood is more durable. To centralise the wooden faceplate onto the sanding disc, I describe a circle slightly larger than the diameter of the wooden faceplate, so that I can see an even gap around its circumference. If you want, you could make about a 2 or 3 millimeter deep recess that fits the outside diameter of the wood faceplate to make it more secure, but I just screwed the faceplate straight onto the disc. Here I'm just checking to see if there's any wobble of the sanding disc. Unfortunately, there's a slight misalignment of around about 1 or 2 millimeters, which I'll have to take out and true up later on in the assembly. Although not as strong as PVA glue, super glue is great for positioning the two pieces together and then finalising the fixing with screws. I'm just levelling the table so that I can mark the centre position of the sanding disc with regards to the table. Here I'm marking the position of the table against one of the side supports. I now clamp the two side frames together so that I can drill a hole for the pivoting bolts of the table in line. Off camera I made a plywood circle and then cut it in half and then mark the centre of it to make the two pivoting plates which will attach to the table. Having made a mark on the side of the table where the pivoting bolt is to go, I then made the two lines from the pivoting plate and the table correspond. Then I marked out 4 screw hole positions to join the 2 together. Assuming no one has a pillar drill, I'm arranging the side members and packing up wood to the same height as the side members and drilling using the Axminster drill guide system. It's crucial that I do this in order to make the holes perfectly aligned in later assembly. I'm using the same procedure with the Axminster tool guide system to drill the holes, the pivoting holes in the side of the table. The old adage, "you never have enough clamps," is applicable here. I'm now going to drill the holes in the base for the side supports. I need to fix the table in any position between 0 and 45 degrees, and in order to do that I need to make a curved slot, a radial slot in the side of the pivot support. I'm now marking the position of the hole for the bolt that will clamp the position of the table. Now I've drilled a hole through the side support and the table pivot, I insert a brad point drill into the hole and then move the table downwards and scribe an arc using the point of the drill. Then it's a matter of highlighting the arc with a pencil and extending the width of that arc to suit a bolt, i.e. a 6mm wide slot, which I use a jigsaw for cutting it out. I then use a file to smooth out the rough bumps inside the slot so that the slot moves freely against the fixing bolt. Here I'm using a slightly radiused screw chisel to square up the sanding disc. If you haven't got one of these and you still want to use the carbide tip tools, then I suggest you get a radiused tip set, which makes it a lot easier to true up the sanding disc, whereas the straight square tips would be more aggressive and grabby. Off camera I made a couple of brackets with screw knobs to fix to the base of the lathe to keep the sanding disc attachment from moving. If you wanted to be more adventurous, instead of using the aluminium oxide disc, you could use a diamond backing disc, which would obviously last a lot longer. Please note, for safety reasons, switch the lathe into reverse, otherwise the sanding disc will unscrew itself from the rear drive shaft. If you wanted to use a sanding disc normally, you'd have to drill and tap the hand wheel, the lathe hand wheel, and use a brass screw to lock it to the drive shaft.